In this video, we have a 555 timer wired in astable mode. The rate of speed of the LEDs flashing, the output going from high to low, is set by this light dependent resistor. You can see the darker I get the light dependent resistor, the slower it goes. And I'll turn the lamp up a bit. You can see it goes faster, and I can grab my flashlight here and get it going even faster yet, right there. And it's going faster. There we go. I thought it was going faster in person but slower on camera, but it actually did look like it showed up reasonably well. So in any case, we have the output. You can see here the blue LED. It lights up when the output is low because we are having the positive side of the power supply coming to the long lead, the anode of the LED up there, short lead, the cathode, coming down to the output, pin number 3. And then we're using a 1 kilo ohm resistor that helps get the blue LED about the same brightness as the red LED because it's just naturally brighter. Then we got 220 ohm coming out of the output. The red LED will light up when the output's high because you can see down there we have low. And over here we have the schematic where you can see that. So the 555 timer, it begins with the capacitor charging through the fixed resistor, 1 kilo ohm. We need that there because sometimes pin 7 connects directly to ground. So pin 7's off to begin with, and the capacitor charges through these two resistors. And most of the resistance is probably going to be the light dependent resistor, other than when you get it fairly bright. But it's probably more than 10K at this light level. So in any case, that charges the capacitor till pin 6 sees that it's up to 2/3 of the supply voltage. At that point, pin 7 connects to ground so it can discharge, and then the output goes low. So when the output is low, the blue LED lights up, and when it's high, the red LED lights up. But in any case, the capacitor will discharge through the light dependent resistor while the output is low, and pin 7 is also low. Any current that gets through the 1 kilo ohm resistor gets sucked directly to ground as well. So it does not control how long the capacitor takes to discharge at all, just the light dependent resistor. So it will take a slight period of time longer to charge than discharge. Except for extremely bright, it'll take a bit longer because the light dependent resistance will get pretty close to 0 ohms, maybe 40 or 50 if we get it bright enough. But in any case, you can see that circuitry there. We already looked at the output there. There's our 1 kilo ohm coming to pin 7, the discharge pin, light dependent resistor going to pin 6, the threshold pin, a direct connection to pin 2, the trigger pin right there. And so pin 6 and pin 2 monitor the voltage of the capacitor. It charges up to 2/3 supply voltage down to 1/3 supply voltage. You'll also see here pin number 4, that's the reset pin. It's waiting for a low input, a connection relatively close to ground. I think it's actually less than half the supply voltage. But in case we go to the positive rail, that puts 5 volts there. With the 5 volt power supply, tells it to do nothing. It's a high input. So, in any case, that is really about it. We could take a lower value capacitor to go even faster at a given light level, or a higher value capacitor to take longer at a given light value right there. And we'll have a little bit of influence with changing the resistor there, but primarily it's the light dependent resistor, especially if you only change this resistor by a little bit. So 1K works out pretty well. So in any case, that's it for the circuit. Hope you enjoyed. Make sure you check out one of the other videos I'm posting to the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can, that helps out the most. I have links down in the description. But just watching videos helps out a ton. Thanks for watching them. I'll see you in the next video.